Hello and welcome back. I feel like all the sunshine has left. So I might just lean back here and is that better? I think that makes the lighting worse. Man, the lighting is awful in here today. But all right, let's do some math. This is elementary algebra. I am your instructor, Amy Fuchsnyder, and I seem to be obsessed with the lighting today. We are looking at chapter 6. This is on factoring. We're going to look at factoring trinomials today, some basic trinomial factorization. We're going to talk about factoring trinomials by grouping. We're going to talk about greatest common factors, and then we're going to use some mental math. Yeah, we got this. You'll be all right. Okay, so we want to factor a trinomial of the form 1x squared plus bx plus c. I think the important thing to note here is that we are going to start with a leading coefficient of 1. That's not always going to happen, but we are going to start with a very specific form where we have 1x squared or m squared or k squared, 1 times a variable squared plus bx plus c, where 1 is the leading coefficient, b is the coefficient on the degree 1 term or the x term, and c is what we would do the constant. We are going to use a specific strategy where we, first of all, identify the value of b. Then we're going to multiply a by c, a being our leading coefficient, which in our case for today will be 1. Now, we're going to find two integers, positive or negative, who, when multiplied together, give you the value of a times c, or 1 times c in our case, but whose sum would be equal to b. So we want to add to c, we want to sum to b. We're going to break that middle term apart to express it as the sum of those two integers, and then we're going to factor by grouping. If you don't remember factor by grouping, we did it at the end of 6.1, so you may need to review that before moving ahead here. We're then going to check our factors using multiplication. That's the FOIL method. That again is back in 5.6. 5.6, I believe we did that. So if you need to review that, go back to 5.6. And we're going to use that foiling method to check our answer. Okay. All right. I should mention that there will be some trinomials for which this method will not work. Those are known as prime trinomials, and we will bring them up when we get to them. We're not starting there, though. We're going to start with something a little bit easier. Okay. So here's what we got. Let's try it with problem number 1, remembering our strategy. We have a squared plus 6a plus 8. Our a is a 1a squared, so we do meet the leading coefficient of 1. Our b value is the 6, and our c value is 8. We want to find two numbers who sum to, so we want two numbers with a product multiply to give 8, but they add to give 6. We actually want them to multiply to give 8 times 1, which is 8, but we want them to add to give 6. So if we write out the factor pairs for a positive 8, the factor pairs for a positive 8 would be 1 times 8, 2 times 4, or a negative 1 times a negative 8, and a negative 2 times a negative 4. Remember, we want those factor pairs to be positive or negative, right? Which one of these factor pairs will also add to be 6? As I'm looking at these factor pairs, I need them to add to be a positive 6. That would be these guys. So the pair I'm choosing to use is 2 and 4 because they multiply to give me 8 and they add to give me 6. Once I have done that, I want to express my middle term, 6a, as the sum of those. So I'm going to rewrite this as a squared plus, and I'm going to break that 6a apart into 2a plus 4a plus 8. So I've broken that 6a apart into two different terms, 2a and 4a. They added together will still give me 6a, but now I can factor by grouping. Now I can look at my first pair, a squared plus 2a, and I can pull out an a, leaving me with an a plus 2. And I can look at the second pair, and from that pair I can pull out a 4, leaving me with a plus 2. Now that I have a plus 2 in both of these, I can pull that a plus 2 out front, leaving the a plus 4 as my second factor. This gives me the two factors, a plus 2 and a plus 4. If I wanted to check them, I would simply FOIL or double distribute in order to get them together, to get back to the original trinomial. Sorry, a times a is a squared first, outside is 4a, inside is 2a, last is 8, or a squared plus 6a plus 8, and it does check with the original problem. So these represent the factored form. Factor 1 is a plus 2. Factor 2 is a plus 4. This and a squared plus 6a plus 8 are equivalent expressions. They mean the same thing, but they are in two different forms. Okay? All right, let's try problem number 2. Problem number 2 is x cubed minus 13x plus 12. So I need the factors. So I want to multiply to give me a positive 12 times 1, or 12. When we want to add to give a negative 13. Okay, so if I'm writing this out, I'm doing a 12, and I'm going to do the factor pairs of 12. That's a 1 and a 12, a 2 times 6, and a 3 times 4. And then I could do them as negatives, a negative 4 and a negative 3, a negative 6 and a negative 2, and a negative 12 and a negative 1. Do any one of these pairs add to be a negative 13? Now, negative times negative is positive, and negative plus negative, I think we're talking about this one. Right? That pair, when multiplied, gives me a positive 12, but when I add them, I get a negative 13. So now I want to express this middle term as the sum of those. So I'm going to break this middle term apart using this factor pair. So I'm going to have x squared minus 12x minus x plus 12. Right? Just wrote it out that way. Now I'm going to look at the first pair. And if I look at the first pair, x minus 12x, I'm pretty sure I can pull an x out of that. And then if I look at the second pair, I've got a minus x plus 12. Nothing comes out of both x and 12, but remember, we talked about what happens when nothing comes out, like if they don't have a common factor. Normally we would do a 1, because that's the only common factor when there really isn't anything else. But this leads with a negative. So I'm actually going to pull a negative 1 out. And then that's going to go to x. And then I have 12 pulled out a negative 1, so that's going to be minus 12. And if you do this right, because we're practicing, so it should be working out for you. When we're practicing, we try to set up the problems so they work out. So this should be the same in both of them, And it is, we're overheating, I think. Okay. And it is the same in both of them. So I can pull that x minus 12 up front, and I'm left with, when I pull an x minus 12 out of this, I'm left with an x. When I pull an x minus 12 out of this, I'm left with a 1. And so in factored form, this is x minus 12, x minus 1. Now I should mention that this is the same as if I had reversed it and done x minus 1, x minus 12. The order of the factors does not matter here, just that you have both of them. The same way that 12 is 3 times 4 or 4 times 3, and the order doesn't matter, is what we're doing here, okay? All right, so if we have p squared plus 5p minus 14, we are looking for numbers that multiply to give us a negative 14. And the factor pairs of a negative 14 would be a negative 1 with a positive 14, a negative 2 with a positive 7. Or I could do a negative 7 with a positive 2 and a negative 14 with a positive 1. It's important to consider, particularly when it's negative, both positive and negative pairs, right? Because if you don't, a negative 2 and a positive 7 gives you a different sum than a negative 7 and a positive 2. We need two numbers that will add to be a positive 5. That's this guy, right? So that means I'm going to take my 5p and I'm going to break this apart using this factor pair. This is now going to look like p squared minus 2p's plus 7p's minus 14. That 2 and 7 are my guidelines for how to get a 5p. It's a negative 2p and a plus 7p. Now looking at this, when I look at just the first two, I see I can pull a p out. And when I look at the last two, I see I can pull out a positive 7. Now that p minus 2 is in both of them. So I'm going to pull that out front. And that leaves this term with just a p and this term with a 7. If I'm unsure, I multiply back. That's p squared plus 7p minus 2p minus 14, which is p squared plus 5p minus 14. Check, check. This is the correct answer. P minus 2, p plus 7 is the factorization of p squared plus 5p minus 14. Right? Okay. Z squared minus 3z minus 10. It is a trinomial. It leads with a 1. I need the factor pair, that's what I want to say, the factor pair that multiplies to give me a negative 10. Those would be a negative 1 and a 10, a negative 2 and a 5, a negative 5 and a 2, and a negative 10 and a 1. There we go. Which one of these four pairs will add to give me a negative 3? That's this guy. Being careful of my signs, this is z squared minus 5z plus 2z minus 10. Looking at the first two, I see I can pull out a z, and I'm left with z minus 5. Looking at the second two, I see I can pull out a 2, and I'm left with z minus 5. Now, I have z minus 5 in both of them, so I'm going to pull that z minus 5 up front, leaving behind for the second set of parentheses a z and a plus 2. Again, I can check my work by multiplying back. The first is z times z is z squared. The outside is 2z. The inside is a minus 5z, and that's minus 10, or z squared minus 3z minus 10. And that checks with that. So this is the factorization of that trinomial. All right. Great, let's see what else we got. Some more examples. Making things just a little bit different. Now, how do we want to do number 5? Ooh, number 5 has a leading coefficient. It's okay. It's okay. We got a leading coefficient there. That's not a positive 1. That is not a positive 1. But I can do something here. I can pull a negative 1 out. If I pull out a negative 1, then I'm left with x squared plus 5x minus 6, because all my signs are going to change, right? So now I'm going to look at a minus 6. It's going to be a minus 1 and a 6, or a minus 2 and a 3, or a minus 3 and a 2, or a minus 6 and a 1. Do any one of those factor pairs, those two numbers that multiply to give me a negative 6, will any of those pairs add to give me a positive 5? That one will. Sometimes we forget the ones with the 1. Okay. So when it starts getting a lot, I draw a line down here. So now I'm just going to do this. This would be x squared. I'm going to break this into a minus 1x plus 6x minus 6. From the first pair, I can pull an x. From the second pair, I can pull a 6. I got x minus 1 in both of them, leaving me an x on the first one and a 6 on the second. And I just need to remember that I drew that yellow line because I need to put a negative 1 out front. That negative 1 needs to come all the way down. And that gives me 3 factors for this trinomial, all because it led with a negative. All because. All right, let's look at problem number 6. Problem number 6 is x squared minus 7xy minus 12. So I want the factors of a negative 12. 1 times a negative 12, a negative 12. So I'm going to do a negative 1 and a 12, a negative 2 and a 6, a negative 3 and a 4, a negative 4 and a 3, a negative 6 and a 2, a negative 12 and a 1. I need the pair of numbers that will multiply to give me a negative 12, but when added, I get a negative 7. Okay. Nothing is jumping to mind, but I'm just going to go through meticulously to check. So negative 1 plus 12 is a negative 11. Negative 2 plus 6 is a 4. This is negative 3 plus 4 is a 1. Negative 4 plus 3 is a negative 1. That's a negative 4, and that's a negative 11. None of these pairs will add up to be a negative 7. What does that mean? Since no pair that multiplies to the negative 12 also adds to negative 7, this trinomial is prime. It cannot be factored, and therefore we call it prime. Prime is not something you're going to get a lot, but it does happen. So we want to be sure that you understand when it will occur. You will get a prime trinomial when the factors of the A times C do not sum to the B term. That's when you get prime, right? So let's see if we've got another one here. I don't know how many we've got. I don't know if these next 3 are or not, but let's just run through it, right? So for this guy, we do have a trinomial. It does lead with a 1. We want the factors of 6 that will add to be 4. Well, factors of 6 are 1 and 6, 2 and 3, -3 and -2. Or we could go with a -6 and a -1. None of these pairs add to, no pairs also add to 4. So this guy would also be prime. Right? Okay. What about the last one? That's, I think it's also going to be prime. And here's how I'm jumping ahead, right? I'm not showing a lot of work here, but if I do a -12, that's going to be all the same factor pairs as here. So I can do them all over again, but I really don't want to. But if I do all those same factor pairs again, so -1 and a 12, a -2 and a 6, a -3 and a 4, or a -4 with a 3, a -6 with a 2, and a -12 with a 1. Again, none of them will add to be a positive 7. So we have no pair, again, that multiplies to -12 and adds to a positive 7. So again, it's prime. I mean, we want it to be because we know 7 is a 3 and a 4, but the signs have to be different in order to get a -12, and they have to be the same to get a positive 7. And they can't exist. It's not a quantum existence here. They can't be both places at once. Either the signs have to be the same or the signs have to be different. And they can't, since we're talking about two numbers, it can't hold both states at the same time. It ain't chemistry, people. It ain't chemistry. All right. So this is also prime. So there's 3 examples of primes, and I think there's a couple more as we move through this. They're going to come up. I'm pretty sure of it. All right. The goal number 2 is factoring completely. We did talk a minute about this. I think I only have 2 examples of this. So sometimes when you look at these terms, the first thing you want to do, I shouldn't say sometimes, I should say all the time. When you look at these trinomials, the first thing you want to look at is whether or not you can factor anything out. Common factor first, what we were doing in section 6.1. So if I've got a 4m to the 5th minus 8m to the 4th minus 32m to the 3rd, I'm looking at the 4, the 8, and the 32, and I'm thinking, yeah, I can pull a 4 out of all of those. I for sure can. Then I'm looking at the m to the 5th, the m to the 4th, and the m to the 3rd, and I'm thinking, yeah, I can pull an m to the 3rd out of all of those. And that's going to leave me with an m squared minus 2m. What's that going to be? 4 minus 8. Okay, so once I pull out the greatest common factor first, that leaves me with an m squared minus 2m minus 8. Now, this is a trinomial. This is exactly what we've been practicing. So I'm going to see if this can get factored. Is there a factor pair for -8 that will add to be a -2? So that's a -1 and an 8, a -2 and a 4, or a -4 and a 2 with a -8 and a 1. And I'll be darned if this pair adds to a -2m. So I draw the line here just to remind myself that I have other factors over here, but I'm just going to work on this trinomial now. So this will be an m squared minus 4m plus 2m minus 8. Remember, I'm using these two terms to break this apart into those two coefficients. So minus 4m plus 2m. Then I'm going to look at the first pair and pull out an m minus 4. And I should also be able to pull something out of the second pair. And sure enough, I can pull a 2 out. That's m minus 4. Now I've got m minus 4 in each. I can pull that out front, m minus 4. And then I've got a second one of m plus 2. Bringing my 4m cubed back down, I've got a full-on factorization of 4m cubed, m minus 4, m plus 2. Beautiful. Okay. If I want to check it, I can multiply all that back, but at some point, you decide to do a crapshoot. All right. Let's look at problem number 10. I've got a negative 2x squared y plus 12xy plus 16y. I see all of those are divisible by 2, and I see I'm leading with a negative. So I'm going to pull out a negative 2. Then I've got an x squared and x and nothing, so I can't pull any x's out, but I can pull out a y. And that's going to leave me with x squared. Ooh, not plus, minus 6x, because it's a positive, and I pull out a negative. So it's going to leave me minus 6x. I got a positive, I'm going to pull out a negative, minus 8. Okay. So I see I have a greatest common factor, and I see I have a trinomial. So I'm going to see if that trinomial is factorable. All right. So what are the factors of a negative 8? Oh, thank you, Amy. You just did that one. Negative 8 and 8, negative 2 and 4, negative 4 and 2, negative 8 and 1. Do any of these factor pairs add to be a negative 6? They add to be a negative 7. That's going to be a negative 2. That's going to be a positive 2. That's going to be a positive 7. So this is a prime trinomial again. And again, it's a prime trinomial because no factors of negative 8 add to negative 6. Right? And as such, I have a prime trinomial here. That doesn't mean this whole thing is prime. I found three factors. I've got the negative 2y, but then I have the x squared minus 6x minus 8. And if I'm asking, is this done being factored, that just means this is as far as I can go. Right? It doesn't mean that this has to be factored. They can't always. It's a prime trinomial. So this is as far as I can go with factoring. Okay. All right. We're going to use mental math. Okay. So all right. I believe this is goal number 3, right? Yeah, this is goal number 3. I don't think I somehow lost it here. But this is goal number 3. We want to factor trinomials of the form 1x squared plus bx plus c using FML. I know what that stands for, really. But it's really sort of a FOIL mental math. I think that's what it stands for. I don't remember what FML stands for. FOIL, forward mental math, something like that. All right, so our strategy for this is we want to be sure that A is equal to 1. If A is not equal to 1, if we're not leading with a 1, we want to factor out a greatest common factor. If there's not a greatest common factor, then you can factor by grouping if you like. We're again going to determine our factor pairs for C. We're going to identify those factor pairs that add with B, but we're going to fill in the polynomial with those numbers. The order does not matter. Here's what I want to show you. I'm going to go back to our factoring by grouping. Where is that one? Oh, there we go. And I just want to see if y'all came up with the pattern or not. So this is our very first page. This is why I first introduced the factoring by grouping as a method here. Look at the two numbers that multiplied to give you a positive 8, but added to give you a 6. And then look at what happened in our binomials. Do you see how we had a pair of 2 and 4? And it was 2 and 4 that we needed in our binomials in the end? What about number 3? In number 3, we needed the factors of a negative 14 that added to be a positive 5. And we came up with negative 2 and 7. Look at what our factors ended up being, p minus 2 and p plus 7. Similarly, when we had a positive 12, right, the factors that we ended up using were a minus 12 and a minus 1. Look at what our factors ended up being, x minus 12, x minus 1. Here we had a negative 10 needed to add to a -3, so we chose the -5 and the 2, and our factors ended up being z minus 5, z plus 2. That means that some of you will be able to short circuit all of this whole process. Now, we can short circuit this process and shortcut it slightly. However, the part that you need to understand is that this only works if you've done the first step. If our A value, if our leading coefficient is 1, if it is not, if your leading coefficient is not 1, this short circuiting using a mental math will not work. It simply will not work. You will get them all wrong, okay? So, one simple check. All right, let's try some of these. We'll show you how quickly it can go. So here we have m squared plus 7m plus 6. First of all, do you have a leading coefficient of 1? Well, it's not written, but it is. It is 1m squared. So, right, this would be a 1m squared. Check. That means that I can use this method. What factors of 6 also add to give you 7? Well, that's a 1 and a 6. Or a 2 and a 3. Or a -1 and a -6. Or a -2 and a -3. If at any point you hit upon them, you use it. The 1 and the 6 will work. So this factored will be m plus 1, m plus 6. If you're not sure, particularly because you're using mental math and you may not feel secure about it, go ahead and multiply back. This will be m times m plus 6m plus 1m plus 6, or m squared plus 7m plus 6. Yep, you did it. Okay, let's look at problem number 12. Does it begin with a 1? Yes, indeed, it does. So I can use this shortcut method. That means I want the factors of a 5. Well, 5 is a 1 and a 5, but since it's positive, it could also be -1 and -5. Do either of these add to be a -6? The second one sure does. That tells me that my factors here will be k minus 1 and k minus 5. Again, if I'm unsure, I can check. First, k squared, outside minus 5k, inside minus 1k, last plus 5, or k squared minus 6k plus 5. And it checks. So this is correct. All righty. What about number 13? Those numbers are awfully low. This one could be a little bit harder. Does it lead with a 1? It sure does. There's a 1 there. That means I can use this method. All right, the factor pairs for a 1. Well, that's a 1 times 1, or a -1 times a -1. Do either of those pairs add to 2? Why, yes. That first pair will add to 2. That tells me these factors are x plus 1 times an x plus 1. I would want to rewrite this. Oops, I went too fast. And there we go. All right, I would want to rewrite this. Here we go. Yeah, I would want to rewrite this as x plus 1 squared, because that's simplest form. X plus 1 times x plus 1 is the same as x plus 1 squared. Here we go. Great. What about number 14? I have a y squared minus y minus 12. Here I have a minus 12. Can you think of a factor pair of -12 that will give you, a negative y? Oh, let's remember, it leads with a 1, and there is a 1 there. So I also want a factor pair of -12 that, when added together, will give me a -1. Some of you already have it. If you don't, be meticulous and write things down. -1, 12, -2, 6, -3 times 4, -4 times 3. Oh, and maybe at that point you see it. Maybe you don't. If you don't see it, you keep going. -12 times 1. Which one of these pairs, when added together, will give you a -1? -4 and 3. This gives us our factors of x minus, whoops, not x, that's a y. Y minus 4, y plus 3. Right? Again, if you're not sure, First, y squared, outside, 3y, inside, 4y, last, minus 12. Or y squared minus y minus 12. It's the same thing. It checks. This is my answer. I just spent more time checking the problem than I did coming up with the answer. Depends upon where you are in life. All right, here I have a squared plus 2a minus 15. We're overheating, I think. There we go. A squared plus 2a minus 15. The factors of a negative 15 that will add to be a positive 2. I right away went to 5 and negative 3. Because I have fluidity with my mental math, I'm able to do that. If you're not, write through the list as I did with negative 12. This tells me that I have an a minus 5 and an a plus 5, and an a minus 3. If I'm not sure that those factors are correct, I can do first a squared, outside minus 3a, inside 5a, last minus 15, or a squared plus 2a minus 15. And yes, these would be the two factor pairs that will multiply to give me that trinomial. With number 16, I have a positive 6. And I want the factor pair that adds to be a negative 5. My brain is going to 2 and 3 right away. I think that'll work. But I'm gonna do a 1 and a 6, a 2 and a 3. Nope. I need a negative 2 and a negative 3. That's what I need. And a negative 6 and a negative 1. Okay. So I need the negatives. So sometimes to avoid easy mistakes, right? It's better to write it out. So this will give me a b minus 2 and a b minus 3. B squared minus 3b minus 2b plus 6. Yep, that'll work. All right. Are you feeling pretty confident about this? Great, because I'm going to give you some word problems. Isn't this awesome? All right, here we go. We've got a rectangular fish tank that has a volume that can be represented by the trinomial 2x cubed plus 10x squared plus 8x. The dimensions of the tank can be found by factoring this expression. This makes sense. We're working in a section where we're factoring. So even though they've given us this trinomial, they've essentially said, go ahead and factor it. If the width is less than the height and the height is less than the length, write the expression that represents length, width, and height. Oh, so they've given us an order and they kind of want us to assign length, width, and height, it looks like. Okay, we got this. We got this. They've given us a trinomial. They've told us to factor it. The dimensions of this tank can be found by factoring. We've just practiced factoring. So it's got to be that we're factoring. All right, so I'm going to take 2x to the third plus 10x squared plus 8x. This is a trinomial. And if you want to find what multiplies to give you 8 but adds to give you 10, you are going to get this wrong because you forgot the first rule. Are we leading with a 1? Nope. If you're not leading with a 1, look for the greatest common factor. See what you can pull out of all of these. They're all even, so I can pull out a 2. They all have an x in them, so I can pull out an x. That leaves me with x squared plus 5x plus 4. Now, inside my parentheses, I still have a trinomial. We know sometimes those work out to be prime, but if I use my mental math skills for x squared plus 5x plus 4, what numbers multiply to give me 4, but will add to give me 5? Well, that's 1 plus 4. So this would be an x plus 1 and an x plus 4. Pulling my 2x down, I now have the length, the width, and the height. If the width is less than the height, and the height is less than the width, I don't think this matters. So let's see, which one would be the smallest? I think probably the x plus 1. So I'm going to do width is equal to x plus 1. The height is less than the length. I'm going to say the height is x plus 4. And we're going to say the length is 2x. That will work for everything bigger than 4. That's more information than you needed to know. All right, but I've got the 3 factors. My 3 factors are 2x, x plus 1, and x plus 4. That'll work. Okay. Perfect. Let's try 18. Surface area of a cube is given by SA, for surface area, is equal to 6s squared. 6x squared. If the surface area of a cube can be represented by the trinomial, what expression? Oh man, I don't know what to do. The surface area of a cube can be represented by the trinomial 6x squared minus 12x plus 6. When you don't know what to do, try to remember what it is we're working on. We're factoring. So I think because we're practicing factoring right now, there's probably something to be said for taking 6x squared minus 12x plus 6 and factoring it. I can pull a 6 out of all of those, right? Doesn't start with 1, so I want to pull a 6 out. So that's going to give me 6 times x squared minus 2x plus 1. Now, that trinomial does have a leading 1. So if I'm dealing with x squared minus 2x plus 1, so I could use the mental math or I could use the factor by grouping. They both kind of start the same though, right? I need the factors of 1. That would be 1 and 1 or negative 1 and negative 1. This is the pair that adds to negative 2. So this would be x minus 1, x minus 1. So if I were to simplify this, I could write it as 6x minus 1 squared. Surface area of a, okay, so I factored it all the way. Now, can I pull this back to the first piece of information? The surface area of the cube is given by SA is equal to 6s squared. This says the surface area is 6x plus 1 squared. Oh, do you see how the x plus 1 is in the same spot as the s? So 6, those are the same. But then instead of s squared, which is the surface area, it's got x minus 1 squared. So that could mean that my s is equal to x minus 1, right? What expression will represent the length of a side? And I bet you s stands for the length of a side. So the side is x minus 1. There. All right. That's it for 6.2 and some factoring. Hopefully you liked, you were comfortable with both methods, the mental math and the factoring by grouping. The factoring by grouping I stressed because that's going to come back up a little bit later again. We use that all the time. Use the mental math on a lot of the ones like I did in the end here that started with the 1. But yeah, that factoring by grouping comes in real handy. And if you like it, you can use it all the time. You don't need to do the mental math if you don't like to. So, I mean, we want you to because we want you to get very fluid with it, but at least for now, you can hang on to that factoring by grouping. Okay. All right. If you have any questions on anything, please don't hesitate. You can contact me. The Math Center is open. I believe this is if this is a Friday assignment, it's only open till 4, but it is open on Sunday. So, all right, hang in there. We're getting to the end. All right. Thank you.